Hello guys, in this video I'll be taking you through a very interesting concept or topic in the mechanical design process, which is functional decomposition. So functional decomposition is basically decomposing the top level function into its various sub functions and understanding the relationships between them in terms of the flow of energy, flow of material, or the flow of information or signals. So functional decomposition is breaking down the top level function into the sub functions and defining these sub functions in the form of function words. So this is the keyword over here. The function words are basically words which define a function. For example, if you are drilling holes into a wall, the function word is over here drill or drill holes. If we take the function word for a vehicle, the primary function of a vehicle is to transport people from point A to point B. So that's the function word. Apart from that, if let's say for example, if you take a machine tool, a lathe, the primary function word is to cut the material or to cut the basically do the turning or facing. That is the function word that for a machine tool. If you take another example, for example, if you take a wiper blade system in a car, the primary function word is to wipe the windshield. That's the primary function word. So when we are defining the function words for each of the sub functions, which together form the larger level, together form the product or system which perform the top level function, then it is called functional decomposition. And we are also defining the flow of energy, signals, or materials, because any function will take place due to flow of energy. For example, a drilling machine will only do its function when it is given electrical energy as an input. When the electrical energy is given as an input, the motor will rotate and the motor will transfer the rotation to the drill bit, and hence that energy is being transferred to the part which is being drilled down. So there is a transfer of energy, there is a transfer of signals, or there is a transfer of materials. If we take the top level function of a drilling machine, the primary function is to drill holes. That's the function word over here in the block diagram. And the input energy which is required to perform this function is in two forms. One is of course the electrical energy, which is coming from the electrical supply. The electrical energy is required to run the motor, which in turn rotates the drill bit and performs the drilling. And additionally, you also require human effort to push the drill into the wall. So there are two types of mechanical energy which is going into the system. One is the human mechanical energy, which you are applying force on the drilling machine to do the drilling, and other one is the rotational mechanical energy, which is being converted from the electrical energy, and that mechanical energy is being transferred outside of the drilling system into the wall or the wood. So the mechanical energy is being transferred into the wall or the wood, which is in turn causing the cutting operation and drilling a hole into the wall or the wood. Now if we are breaking down this top level function, which is overall function of drilling holes, into sub functions, we will be able to understand the various elements of the drilling machine. So the drilling machine, as you can see, has multiple elements to it, or multiple parts, multiple sub assemblies to it, which in turn perform certain functions. So you can see the housing, that is a plastic housing, that is a button which is included in the housing, and there is a chuck which is holding the drill bit, and that chuck is connected to the motor internally. There is a motor inside, and the motor is connected to this wire. So there are multiple parts to the drilling machine, which basically results in its performing the function over here, which is to drill holes. So if you want to understand the various sub functions, here is the block diagram. So here we have converted this black box, which only represents one function word, into multiple function words which all work together to perform this top level function. So let's understand this. First important input which is coming in is the electrical energy, which is going to the motor, which is converting energy from electrical to mechanical energy, and that mechanical energy is being transferred to the chuck, which is clamping and rotating the drill bit, and the drill bit rotation is being transferred to the wall or the wood which is being drilled on. Now, when this operation is taking place, there is human effort in two forms. One is the human effort for the gripping, that is holding this and pressing the drilling machine onto the wall. That is one human effort. Other human effort, which is not happening continuously, is for clamping the drill bit. That is using this mechanism to clamp the drill bit into the chuck. So this function is not continuously working. It's an intermittent function. But this function is has to work, or this function, or we can say this energy, input energy, has to be there to perform the function always. There is another input which is in the form of signal or information, that is drill speed control. So drill speed control is given as an input by the person operating the drilling machine, which says what is the speed of a rotation which has to be given to the motor. So that is given on the button. The button is part of the housing, and that in turn is transferred in the form of speed control signal to the motor, which will change its speed based on the input received. And this these two blocks represent the housing, which is performing a dual function. One is it is housing the whole system, the motor, the internal wiring, and the chuck and everything. It is mounting that, it is housing it. That's the housing, the total housing. Also the button is inside it, and also it is providing ergonomic grip. So the ergonomic grip is being provided by this housing. It is performing a dual function. And there is a vibration and load transfer which is happening between the head of the drill head and the housing. Vibration and load transfer, which is indicated by this arrow, two-headed arrow. And there is mechanical energy transfer between the housing and the motor, because the motor is mounted in the housing. Hence, whatever the forces or mechanical energy or vibration energy which is coming from the motor will be transmitted to the housing as well. So from this block diagram, which is actually a very simple simplification of the drilling machine, we can understand the overall working, internal workings of the drilling machine and the various sub-functions it performs, and allocate those sub-functions to the various assemblies which are there in the drilling machine. If you want to learn more about functional decomposition, you can download a free ebook, the link of which is there in the description below. You can learn about functional decomposition in depth, as well as other very interesting topics in the mechanical design process. So back to the video. This way of decomposition is actually very useful in understanding complex systems and simplifying them into various buckets of function, and then understanding the relationships between those functions with respect to the flow of energy, materials, or signals or information. Here is another example of a breakdown of a larger top level function into smaller sub functions within the system. So if you are having an electric vehicle, the electric vehicle has multiple systems, and it is basically providing the function of providing transport, from transporting people from point A to point B. That's the most fundamental function which a vehicle performs. To perform that function, it requires electrical energy, and of course it requires human intent to actually drive the vehicle. It requires this information for it to actually perform its function of transporting people from point A to point B. And the outputs are of course in the form of movement, that is mechanical kinetic energy, which is being expended by the vehicle for movement, and also the movement of the vehicle or the behavior of the vehicle is given as a feedback for control. So the way the vehicle is moving is used as feedback for the person who is controlling the vehicle. So that is also an output which is fed back into the system. Now this top level product can be broken down into multiple sub functions. One of the sub function is the operation of the electric motor. So the electric motor, what it is doing fundamentally is converting electrical energy into rotational mechanical energy. This is the most fundamental we can say functional breakdown of a system of which is having an electric motor. So this electric motor will be part of a larger system which is the electric vehicle, and it is a sub function of a larger system which is the electric vehicle. The electric vehicle will have the electric motor inside it along with many other systems, many other components, many other assemblies which are performing various other functions. For example, the chassis will perform the function of load bearing, being providing rigidity for the vehicle, providing safety for the occupants. That is a function which is providing. Similarly, the suspension system is providing the function of reducing the vibrations which are going into the occupant compartment, which is basically giving good ride comfort to the occupants. So there are various functions which a car performs, various sub functions which a car performs, and one of the primary sub function which of the electric vehicle is to convert electrical energy to rotation mechanical energy through the electric motor. Similarly, we can understand functional decomposition with the example of a suspension system and the coil spring inside a suspension system. So a suspension system as a whole, if you are considering that as a top level product, it is performing the function of supporting load, constraining the wheel and damping vibration. So these are the three primary functional words or functional characteristics which this suspension system is having or it is performing. And to perform that, it requires energy from the wheel, that is the kinetic energy from the wheel, the disturbances which are coming in from the road. That energy it requires to perform its function, and the output is in the form of a heat energy from the damper to the environment. So input is mechanical energy, and the main purpose of the suspension system is to absorb that energy and to damp the vibration, and when it absorbs that energy, it expends the energy absorbed, a portion of the energy absorbed in the form of heat energy from the damper to the environment. So the output is heat energy from damper to the environment, and this whole suspension system is having a coil spring inside it, which is shown over here. So the coil spring is performing a sub function, and that sub function is to store and release energy as the suspension goes up and down or the wheel goes up and down. It stores and releases energy. So the input is that the mechanical energy from the wheels comes in, and then once it is rebounding, it releases that mechanical energy, and this keeps happening in the suspension system continuously, and that is nothing but that defines the function of the coil spring. The coil spring is basically a device which is used to store and release energy. That's the primary function of a coil spring. So you can see how top level systems are being decomposed into elements, into various mechanical system elements, or we can say machine elements, which are performing individual functions, and those individual functions are then coming together to perform the top level function. Why is functional decomposition important for design engineers? First, if we are doing functional decomposition of a system, we are understanding the system better. We are understanding what energy comes into the system, what energy is going out of the system, what kind of signals or information is required to run the system, and what are the interrelationships between various sub-functions. We understand the system better, and hence when we understand the system better, we can design it better. Second, the possibilities of combining functions. So for example, if there are two sub-functions, as in the case of the housing and the ergonomic grip, so there are two functions which are being performed by the same component, which is the housing. The housing is giving the grip, ergonomic grip, and also it is connecting all of the components together in the whole package. So what are the possibilities of combining functions? By understanding this functional decomposition, we will be arriving at possibilities of combining functions. Third, if there are, again it's similar to the second point, identifying redundancies in design. If there are two components which are performing similar functions, then we can combine them together. Tracking functional relationships, this is also very important. If you want to track functional relationships between various sub-functions, this functional decomposition diagram will be very helpful. And when it comes to DFME, that is design failure mode effect analysis, which is having functional analysis as a very integral part of it, we can understand, we can relate failure modes to sub functions by using this functional decomposition. So if you're making a functional decomposition diagram of a system, and if you're having the DFMEA, and if you're having a failure mode, then we can relate that failure mode to the various sub functions which are being affected.